Okay, today we're going to make some buildings with repeatable windows on them. It'll be a little bit inspired by procedural buildings in games like Townscaper and Tiny Glade. So I've got a default scene. I'm going to first make the window. I'm going to just rename the default cube window. Scale it taller, edit it, add a loop, make a peak. What I'm going to do is I'm going to take these top vertices, add them to a group, assign them a weight of 1, call it peak, because what we're going to want to do is be able to edit the slope of this peak. Stick a bevel modifier on here. You can see right now it's beveling all the corners, but what we're going to do is we're going to say target vertex groups, just the peak. Now I've got a nice curved roof that we can edit procedurally. Also, I'm going to apply all the transformations because now these are all set to 1, and this is the shape of the window versus it being a short window that's being stretched out. And for now, we are going to just hide this. Okay, next we're going to make the system to put these windows on a building. So what I'm going to do is I'm going to add, this will seem a little odd, but I'm going to add a sphere. And why I'm doing this is we're going to put geometry nodes on here and we're going to generate our building. And I just want to show you that the cube that we're going to use for the building and the windows are going to all be generated within our geometry node setup, and that this actual initial geometry didn't matter. So we're going to make a geometry node setup that you could put on any geometry. So I'm just making it a sphere to show that the sphere actually wasn't part of the final output. So I'm going to go into geometry nodes. We're going to make a new network. I'll just call this a building. So you can see here, we've got our input geometry, which is this sphere, and our output, and I can disconnect this and we actually don't get that sphere. What I do want is a cube. And then I'm going to do a join because we're going to want multiple things coming out. Get this a little bigger. I'm going to put a grid. So this grid, and we've got a cube, and you can actually see it here. There's a grid and a cube. We're going to use the grid to generate the windows and then cut them out of the cube. So what I want to do is be able to transform the grid. Make sure we're viewing our wireframe. This is going to be helpful. So this grid, what we want to do is maybe bring it out so it's sticking halfway out the cube, and then we're going to rotate it. So now what we've got is a cube and a second piece of geometry that's essentially just a grid of vertices on one side of the cube. And if you think of this grid as registration points for where we're going to put the windows. So what I'm going to do is I'm going to drag from these connection nodes into the grid dimensions. I'm going to rename these width and height. So now when you put this geometry node on any geometry, you'll be able to control how many subdivisions we have in the width, how many we have in the height. So what we want this to do is add spacing evenly in between the windows. So if you imagine we're passing in a 3 right now, but we're only getting 2 spaces in either direction, what we're going to do is add a math node, set it to subtract, duplicate it because we're going to want one for the width and one for the height. We're actually going to pass this in here, and we want one less than the width and one less than the height, and that's going to give us the amount of spacing. So then you go for that amount of spacing, duplicate a math node, set it to multiply. You go for that amount of spacing, we want X amount of width. And what we're going to do is we're going to set this into the grid width, grid height. And also, we want to scale our cube as well, so we have more room for the windows. We've got this size attribute that has an X, Y, and Z. So what we need is a combine X, Y, Z. Set these all to 1. We'll pipe in our X, pipe in our Y. Now, if we're lucky, oh goodness, what's going on here? It's our, I think it's our Y and our Z. Yeah, here we go. Now we're able to add more spaces and we get our subdivisions spacing out relatively evenly. So if you imagine what we want to do is generate a window on each point, we actually need padding around the edge of this so the windows aren't falling off the edge of the house. I'll show you real quick what that's going to look like. So right now, I'm going to say for every vertex on our grid, we're going to put an instance of an object, and that object's going to be a window. But they need to be scaled down. So you can see what I mean by the windows are on the vertexes and we need some padding. So to do that, all we're going to do is, before we combine our values into the cube, we're going to add a little bit. And you could pipe this in from the group input and control it. You could do a little math and figure out how to orient things to get more padding on the top versus the bottom, but for our sake, we're just going to add enough padding where the windows don't fall off the edge. Cool. So this is starting to look pretty cool. What we can do is, instead of just joining this geometry, what we want to use is a mesh boolean. So what we're going to say is we're going to take our cube, sorry, zoom in on this, and essentially subtract our windows, and that'll be the output, not the join. It's not the cleanest edge loops, but it's nice and procedural. You can get any width and any height you want of windows. This can kind of be taxing on your system, so you could do something saying like, oh, we want a maximum of 8 for the height, 8 for the width, then you go in here and you can scrub in these and not worry about crashing your computer. So next, I'll show you something cool. Now that we've got this set up, I don't like looking at the ugly edge lips. Now this set up, you can go in, make a bunch of buildings. Very cool. Another thing you can do, and kind of what I was getting at with the starting with a sphere, is this setup doesn't use the input node's geometry. So in theory, I could stick it on any piece of geometry and it's going to receive the height and width inputs. It's going to be pulling from that window geometry, generating a grid, generating a cube, and then outputting your building. So you could put it on, drag and drop it on anything that you want to be a building, and the original geometry didn't matter. Okay, another little trick I'll throw in here, because since we are generating these through geometry nodes, this actually doesn't receive the material that you put on it, and the reason is this geometry isn't the base geometry, it's geometry that's generated within the node. So call this building, and I'm going to add another, I'm going to call it window. And so what you can do in here is add a set material node. I'm going to put one on the windows, one on the building. Here we're going to put building. Whoops, that's the window. Here on the building. You go, okay, now I've got a geometry node set up that gives me a red house. So what if I wanted this to be a little more dynamic or interesting? What we can do is we can go into our shader editor. We want to be in our building. Okay. I'm going to add a hue saturation. I'm going to grab information from our object saying when this is applied to an object, we're going to generate a random value. And that value we're going to apply to the hue of this red. So now we actually get randomized colors. Every time we apply this geometry node to a setup, it generates a new instance of this shader and grabs a random value. Okay, so now you go, it's nice I've got a random color, but what if it's not a clown town where every single building's a random color? What we're going to do is I'm going to add a map range. So if this random value is going from 0 to 1, we're going to do is put this in here, and we're actually going to go, you're only allowed to go to from 0 to 0.3, and you get much less randomness. And then we can do, let's do a math node here, and value we'll call hue, stick it in here. Now you can change how broad the color change is, and then you can shift it along the color spectrum. So imagine you can go in here too, and you could tweak this to be something more realistic. And add as much math and conditionals as you want in here to get kind of like the amount of variation you'd want within this type of house you're generating. Cool. I think that's it. Obviously, there's a million different ways you can do everything, but this kind of gives you an idea of how you can use grids of vertices to create repeating patterns and output them into geometry. Thank you.